Bismillahirrahmanirrahim. High voltage technology, and today our topic is breakdown theories and the mechanism in liquid dielectric. The first theory is the suspended particle theory. So the commercial liquids will always contain solid impurities either as fiber or as dispersed solid particles. The permittivity of these solids epsilon 2 will always be different from that of the liquid epsilon 1. When the high voltage applied across two electrodes immersed into the liquid, the particle get polarized in the electric field E applied between the electrodes. Assume these particles to be sphere of radius r. These particles get polarized in an electric field E and experience as a force which is given by F is equal to r cube, where r is the sphere, the radius of the sphere of particle. Epsilon 1 is the permittivity of the liquid dielectric. Epsilon 2 is the permittivity of the contaminant particle, and this is d, the divergence of E. If this field exceeds the breakdown strength of the liquid, the local breakdown will occur near the particle, and this will result in the formation of gas bubbles, which may lead to the breakdown of the liquid. The values of the breakdown strength of the liquids containing solid impurities was found to be much less than the value for the pure liquids. The impurity particle reduces the breakdown strength, and it was also observed that the larger the size of the particles, the lower were the breakdown strengths. Okay, we have to discuss the two cases. If epsilon 2 is greater than epsilon 1, means we have the case of the solid contaminant in the liquid dielectric. And then case 2, we have to consider the gaseous contaminant in the liquid dielectric. Okay, so first case, for example, in the case of the presence of the solid particle like paper in the liquid, this force is directed towards the areas of maximum stress. Okay, now if epsilon 2 is less than epsilon 1, means if only gas bubbles are present in the liquid, the force will be in the direction of the areas of the lower stress. If the number of particles present are large, they become aligned due to these forces and thus form a stable chain which bridge the electrode gap, causing a breakdown between the electrodes. If there is only a single conducting particle between the electrodes, it will give rise to local field enhancement depending on its shape. Okay, now the second theory is the cavitations and the bubble theory. In practice, it is difficult to achieve 100% pure dielectric without any sort of impurities. The more common factor responsible for the breakdown of the liquid insulating material is formation of the cavity and the bubbles in the liquid. Processes have been suggested to be responsible for the formation of the vapor bubbles are the gas pockets, electrostatic repulsive forces, the gaseous products, and vaporization. The pockets are the results of the heat, and gas pockets are formed at the surface of the electrodes. And the electrostatic repulsive forces between the space charge which may be sufficient to overcome the surface tension, and the gaseous product due to the dissociation of the liquid molecules by electron collision, while the vaporization of the liquid by corona type discharge from the sharp points and irregularities on the electrode surfaces. It has been suggested that the electric field in a gas bubble which is immersed in a liquid of permittivity epsilon 2 is given by EB is equal to 3 E naught divided by the epsilon 2 plus 2, where E naught is the field in the liquid in the absence of the bubble. When the field EB equals the gaseous ionization field, discharge will take place, which will lead to decomposition of the liquid and breakdown may follow. This is the simple equation for the EB, and for the complete and the more precise and accurate expression for the bubble breakdown strength is given by this VB EB. Okay, where this sigma is the surface tension, epsilon 2 is the contaminant, permittivity epsilon is the dielectric, mm, epsilon 2 is the liquid of permittivity, and epsilon 1 is the contaminant permittivity, where E naught is the field in the liquid in the absence of the bubble. Okay, it can be seen that the breakdown strength depend on the initial size of the bubble, which of course depend upon the hydrostatic pressure above the bubble and the temperature of the liquid. This theory does not take into account the production of the initial bubble, and hence the results given by this theory do not agree well with the experimental results. The third theory is the breakdown in liquids. Okay, the stressed oil volume theory. Dielectric field or the breakdown strength of the liquid is a function of the largest possible impurity or the weak link. It was proposed that the electrical breakdown strength of the oil is defined by the weakest region in the oil, namely the region which is stressed to the maximum, and by the volume of oil included in that region. The breakdown voltage is highly influenced by the gas content in the oil, the viscosity of the oil, and the presence of other impurities. Okay, that was all the reasons and the theories which explains the breakdown procedure in liquid. In suspended particles, force is applied towards the contaminant. In solid, uh, it is directed towards the maximum stress, and while in the liquid and the gaseous bubbles, it is directed towards the lower stress. Okay, and in cavitation and bubble theories, four reasons have been presented suggested: the gas pockets, the electrostatic repulsive forces, the gaseous products, and the vaporization. While in stressed volume, as stressed oil volume theory, this graph explains that greater is the uh, impurity, presence of impurity, lower will be the breakdown value. Okay, so it means the breakdown will occur at lower voltage in the presence of the greater impurity, and if we have the low amount or the low content of the impurity in the liquid background, so we will have a high value for the breakdown. So it means the breakdown will not occur for the lower values. It will occur for the breakdown of the liquid. It will require a greater amount of the breakdown voltage in order to have a breakdown for this liquid dielectric. Okay, so that is all about the theories of the dielectric, and in the next lecture I will show you some video clips in order to demonstrate the testing of the transformer oil, how the transformer oil will be tested in the lab, and the gaseous and the demonstration of the plasma and some arcs which we have studied. So I will show you a video clip uh, for all these topics I have already said. Thank you.